You can also graph the right order. All right, so we're going to find the volume of a solid formed by revolving the region bounded of the graph of y equals x squared plus 1, which is the parabola, okay? Y equals 0, which is the x-axis. Maybe I should do this. X equals 1, which is this line right here. And and x equals 0, which is the y-axis. So we're talking about, so this y-axis, thank you. This parabola, x equals 1 and y equals 0. So we're talking about that little section there is what's in case when you draw all these lines you put in there. So we're going to take this unit and we are going to revolve it around the line x equals 2. Well, x equals 2 is right here. This is x equals 2. So we're going to take a line. There's going to be a line right here, x equals 2. And we're going to take this thing and we're going to revolve it around. I probably didn't go far enough to the left. We're going to revolve that thing around this line. So you got this funky looking object here. That'd be this first circle stuff. So I'm going to do something like this. So you're going to have some kind of a weird object here that's a solid. Looks something like that. And there's going to be a hole. This part in the middle is like a hole going through the object like that, like a cylinder. In the middle of this, there's a cylinder opening. Does that help you see what it looks like a little bit? So that's what we're doing. Okay, I'm going to get rid of all the green stuff except the line. So it almost looks like maybe kind of a candle holder with a hole all the way through it. Oh, so capital R is going to be the distance furthest away from the thing you're rotating it around. The part shaded furthest away. So I hope you can see the part furthest away is this line right here. So capital R, and we're doing a rotation this way, so that means that this is my rectangle and this is my capital R from here to here. So let me change this to blue. And when you're doing a problem like this, the rectangle is going, the little part of the rectangle means this is a dy problem. Because perpendicular to a vertical line, that's a dy. That's why if you make a little rectangle when you're doing this, it helps you know if it's a dy dx also. So since I'm doing a rotation around a vertical line, this is a dy problem. So what that tells me is I've got to solve all this stuff with x. Okay, so when I look at this thing, I got to take this thing right here and solve it for x. So I'm going to have to subtract a 1 over. And then I'm going to square root it. And then I'm going to come over here and look at this. This is the only part of that graph I need right here, right? So is this a positive part or a negative part of this graph? Where's the x value, positive or negative on this side? Here's the y-axis right here. Am I going positive or am I going negative? Positive. So I don't do the negative one here because this part shaded is to the right of the y-axis, which makes x positive over there. So thumbs up with what I'm saying so far. I can't see your thumb, Tom. Oh. These things are pretty hard. All right. So going on. So this right here, it's this equation right here is just that part right there. All right, so R. When you're doing R, you take right minus left when it's a dy. What's the right value up here? 2. What's the left value right here? 0. So that capital R is 2. So my capital R is 2. Okay, then my little r is going to be the closest part So that's this one. I'll bring this purple. So this is the closest part down here. It's still a dy, and this is little r. So little r is going to be 2 minus 1, which is 1. Anybody got a question to there? Now this is kind of screwy. Maybe I should have left my 3D problem up there. But this big R and this little r are going to be the same. These two things from the bottom, which y equals 0 is here, up to where? Where do these two r's work? There's a place that your big R is going to change.
That y equals 1.
Yeah, if you look right here, this stays constant up to here. This right here, this little thing right here is constant up to that 1. So that means on this integral, I'm going to get just the bottom part of that weird looking candlestick. That's the same circle all the way around. It's going to look kind of like a donut. Okay? So the first area or volume is going to be this part right here. So I'm going to start off by getting the volume is going to equal the integral from 0 to 1. And it's 0 to 1 because we're a dy problem and I already screwed up. Anybody know what I screwed up on?
Did it with the pi.
I think I did it on the video too. Okay, this is pi big R squared minus little r squared. So it's pi, okay, and it's 0 to 1, and the formula is big R squared minus little r squared dy. Now that is from here to there with an open circle here in the middle. Okay, that right there is the part of the volume we've got so far, that object. How many are thumbs up to that? Now my big R changes at the top because the big R is no longer the y-axis, it's this thing. You see it change? So now my big R is going to be from this blue parabola over there to that 2. So now this big R on this change is 2 minus the parabola is the part on the left. Well, do you remember we solved for the parabola right here? So this is 2 minus the square root of y minus 1. This is my big R because this right here is the graph of that square root of y minus 1 for x equals that. This is hard, boys and girls. This is tough. All right, so there's big R. Little r, I'm going to use purple again for a reason. Little r is still the opening, the part that's not shaded. Now, I put purple in there again. Why did I do that? Does my right or my left change on the opening space? That little circle, open spot in the middle? No, it stays the same the whole time. There's an open circle all the way up and down. This is exactly the same. So it's still the right minus left. That part's still the 1. Okay. Now I'm going to, this is going to work from y equals 0 up to here. That's y equals 2. Okay. So that's going to be plus pi integral 1 to 2 of big R, which is this 2 minus the square root of y minus 1 squared minus little r, which is 1 squared, dy. Okay? All right. So does that help you see where those come from? Is that the hardest part, just figuring out where the equations came from?
I mean, that and then like a whole, like, towards the end of it with the U substitution.
Okay.
It was all in all.
All right. So let's do this then. All right. So I got a pi here, and then inside I got 0 to 1, and then this is going to be 4 minus 1. This is going to be 3 dy. Okay. This part hopefully is easy for everybody. Plus pi, and then we got the integral from 1 to 2. And I'm going to take this thing right here, and I'm going to FOIL it out. Okay? There's a shortcut to do a binomial square. So you take the 2 and you square it, which is 4. And then it's first term times second term times 2. It's the shortcut. Hopefully you remember that. So 2 times this negative radical is negative 2 of that radical, times 2 is negative 4 of that radical. And then it's this last thing squared, so it's gonna be plus y minus one, because when you square square root, they cancel out. I'm gonna take the parentheses off. And then I got minus one out here, because I gotta take this minus that one squared out there, dy. And then I'm gonna add like terms in this part. So over here, I'm gonna go ahead and do the integral of this one. So the integral of 3 is 3y from 0 to 1. Then over here, I'm going to combine some like terms here. So it's going to be the integral of 1 to 2. And then I got 4 minus 1 minus 1. That's 4 minus 2. So that's going to be a 2. And I got a minus 4 radical. I guess I should do this. Okay. So over here, I'm going to go ahead and plug this one in. So this is going to be a pi. I'm going to have 3 times 1 minus 3 times 0. Over here, I got a pi. And I'm going to do the integral of these parts. So I'm going to split this up into 2 different problems right now. I don't want to do every single step here. Yes, sir.
How did you get rid of the y up there from the?
Oh, that's a mistake. It should not be gone. Thank you. I accidentally left this y off right here, right? Y'all see it? That was a mistake on my part. I'm going to put that plus y right here and put minus 4 there. This y should have been in here. Thank you. Somebody keep me straight. Okay, and then I've got the integral, and I'm going to write this. I'm just going to leave this part 2 plus y, because we can do the integral of this part pretty easily. And then I got plus, and I still got pi in front of this part from 1 to 2. Oops, actually. I'm going to take this, man, that will be what I just put in plus the integral of 1 to 2, negative 4, y minus 1 to the 1/2 y. Now, the reason I'm doing this is because on this part right here, I got to do u substitution. Yeah.
That integral still a pi in front of it?
Yes, it would. There's a pi here too. Thank you. Keep me straight. I'm old. Okay, so over here, I'm going to go ahead and get this part. It's going to be 3 pi. Plus, I got a pi here, and then I'm going to do the integral of 2, which is 2y, and the integral of y is y squared over 2. And that's from 1 to 2. And then over here, I got to do u equals y minus 1. And du is going to equal, so du, but it doesn't look like a u. Du is going to equal dy. I'm going to make a mistake here and see if anybody can tell me what my mistake is. Okay, I just made a mistake. And this is a very common mistake on my class, on my classes on this test. Can anyone tell me the mistake I just made on purpose this time? Leaving the pi off was not on purpose, and the y off was not on purpose. This one was. What's my mistake, Ken?
Did you not take the negative 4 out in front of the integral?
Okay, I could do that or leave it there, it doesn't matter. Yeah, I could have put the negative 4 out here with the pi and had negative 4 pi. That would have been fine. That's not the mistake. There is a mistake though. What variable world am I living in right here or here? Y. What variable world did I go in now? Here. U. There's something that is still in the Y world. What's still in the Y world that should have been changed to a U world? The intervals. This 1 to 2 right here on the right. This is still Y, but I changed the Y's into U's. And when you change to a new world, going from Y's to U's, you got to change this 1 and 2 into the Y world, from the Y world into the U world. So if you take this 1 right here, and what we use is, we use this thing to change it into values of U. It gives me a Y. I take the 1 and I plug in there for this Y right here. And I get 1 minus 1, which changes this bottom integral into 0. And then I took that top number that was a 2, and I get 2 minus 1. It changes this into a 1. That is a super common mistake made on U substitution problems. So you got to be careful not to make that mistake. Okay, so I'm going to come on down here and keep going. So I still got 3 pi here. Over here, I got pi. I'm going to plug in my 2. So I got 2 times 2 plus 2 squared over 2, and then minus the whole thing when I plug a 1 in, minus 2 times 1 plus 1 squared over 2. Okay. And then over here, I got this plus pi. This is this part right here. Actually, let's go ahead and put the minus 4 out there with the pi now. Let's make this minus 4 pi. Taking that 4 out there with that pi. And now I got to do the integral of u to the half. Well, I got to add 2 over 2 to 1 half. I hope you all know that that is going to be u to the 3 halves over 3 halves, but I can flip that upside down and get 2 over 3. And then I got my new u world, so I got to have 0 to 1 out here. How many thumbs up so far? Yes. Then you go back to 1 and 2. Yes. Everybody hear what she just said? Right here, when we're not doing definite integrals, we have definite because we have intervals. We would stick that y minus 1 back in for this, right? And if you can't put the y minus 1 back in for the u, then you have to take your 0 and 1 and it goes back to the y world and go back to 1 to 2. Any thumbs up what I'm saying? That is, you can do that. It takes longer, but you can do that. How many are thumbs up so far where we are right now? You guys are doing a great job. Man, I'm glad to have everybody back. I don't care what anybody else says, I like it. All right, so over here we still got this 3 pi. Now let's start simplifying this other one. So we got, let's see, that's 4 over 2 is 2, and that's 4. 4 and 2, this part right here gives me 6. Then it's minus, let's see, that's 2 plus 1 half. So that's 2 and a half minus 2 and a half. So what is that? That would be 3 and a half, is that right? 7 halves pi. Did I do that right? My calculator's working sometimes. Then I got minus 4 pi, and then I got to plug in my 2/3 times 1 to the 3 halves minus 2, well, yeah, we'll do it like that. 0 to the 3 halves. Okay, so over here, let's see, that'd be 6 halves, right? So 6 and 7 is 13 halves pi, if I add these two like terms together. Minus 4 pi, now 1 to any power is what? 1, and 1 times 2/3 is 2/3. And this is 0 to the power of 0, and 0 times anything is 0, so we got this puppy right here. So we got 13 halves pi minus 8/3 pi. And we're going to, again, we could be done right here, right? Because you don't have to simplify in this class. After you plug the numbers in, you could have stopped right here and been done. But we're going to go ahead and simplify. So I'm going to get common denominators. I'm going to multiply this one by 3 over 3. And this one by 2 over 2. And I'm going to get 39 pi over 6 minus 16 pi over 6. 39 minus 16, is that 23? I think that right there is the answer. Question. I don't remember, is that what I got when I did the notes? Because I think I screwed up a couple places in the notes. All right, I'm going to stop this video.